Welcome to Ask and Learn.
All right, we've got a question here where we've got the series infinity to n equals 1. We have 2x minus 1 to the n power 5 to the square root n power. All right, now here, what we're asked to do is to find the radius of convergence and the interval of convergence of the series. All right, so from here what we would do is we would first set our a sub n's. We know that's going to be equal to 2x minus 1 to the n power over 5 to the n power square root n. Okay, and this is supposed to be this is written wrong. Should be 5 to the n square root. Okay, that's our a of n. And then our a of n plus 1 is equal to the same thing, but we're just going to substitute our n for n plus 1, 5 to the n plus 1, and then finally the square root of n plus 1. All right, so in order to solve for the radiance of convergence, what we do is we take the limit as n approaches infinity, and we take the absolute value of a sub n plus 1 5 to the n plus 1 n plus 1 divided by your a sub n, which is the same thing as 2x minus 1 to the n power over 5 to the n power square root n. All right, and then when you go through and actually solve out this entire limit here, you'll get an answer that looks like 1 over 5 to multiply by the square root of 2x minus 1. Okay, now once you get that value, what you're going to do is you're going to use the ratio test. And you're going to see whether or not this is less than 1. So you would take your 2x minus 1 here over 5, and you're going to determine whether or not it's less than 1. So first you would just multiply 5 on, first you go through and solve this inequality. We can do that by multiplying 5 on both sides. You get 2x minus 1 is less than 5. And then we'll get, it should be an absolute value. I forgot to include that. And so since it's an absolute value, you would also have a negative 5 that it's greater than, right? Because it could be, the x could be negative or positive, and then we have a less than a positive 5. Okay, here what we're going to do is we can then eliminate our absolute value because we've included a greater than negative 5 and a less than 5. What we're going to do is we're going to add 1 on both sides. And then we'll divide by 2. So we'll get our x to be anywhere from negative 2 to 3, not including negative 2, negative 3. Okay, so now that we've got our intervals, what we're going to do is we're going to check to see if the endpoints are to be included. So what we would do is we would plug in negative 2 for our x, and we would solve. And we would plug in, let's see, what's our series looking like here? We got a 2x minus 1 We're setting our x to be equal to -2. And we got that to the -2 power. Oh, I'm sorry. We're substituting x, not n. We're still going to keep our n's to be n, n, n. Okay. And then we'll have a -5 to the n power, 5 to the n square root n. And we know that our 5 to the n, -5 to the n, and then our 5 to the n can be simplified. And we'll get a -1 to the n power over 5, root n. All right, now we want to determine if it's convergent or not. We would set the limit for our part B here, our part B sub n. So we know our combination here would be our A multiplied by our B. Your A would be a -1 to the n power. So your B sub n is equal to 1 over square root n. So what you do is you take your limit as n approaches infinity for your B sub n, which is 1 root n, and you end up getting a 1 over infinity, which is the same thing as 0. We know that if it's equal to 0, by the alternating series test, that's what we're using here, by the way, we can see that it is in fact convergent because it comes to a value. So you can say it is convergent at 0. Okay, we can now check the endpoint when x is equal to 3. So we would have 2 times 3, excuse me, to the n, 5 to the n root n. And so we'd have 5 to the n, 5 to the n root n, which would just be 1 over root n. And here, if we took the p minus test, we know we would say that, well, this can be written as 1 over n to the half. And we know that half is less than 1, therefore the series is divergent. We're using, so let's say half is less than 1 by the p minus test. Therefore, divergence. All right, and then finally, when we write out our interval of convergence, we know it does include -2, so we would put this solid bracket, and we know it doesn't include 3. All right, and then the radiance of convergence can be found by taking our ratio test, and we know that that is when your, let's see here, when that occurs when this here is less than 1. So you would write out a 2, excuse me, let's write that out again. So we have these values here. We have a 2x minus 1 is less than 5. And then we have a 2x minus 1 is less than 5. We divide both sides by 2. So if we just take this part here to determine the rate of radius of convergence. You'd say 2x minus 1 is less than 5. X minus half is less than 5 halves. And you would then say, so this is our standard form here, x minus half, and then whatever it is less than is what we write as our radius of convergence. Okay, and we would say 5 over 2 is our radius of convergence. All right, well, I hope that clarifies the question there. Thank you so much for watching.